Welcome back to Problem Solving and Programming Techniques. At this point, you should have Python installed on your computer and preferably Visual Studio Code so that you can write programs on your own system. We will be starting on Chapter 1, which is just Python Basics. In Chapter 1, we're going to talk about variables, data types, operators, the interactive shell, how to make comments in your code, and some of the built-in functions that come with Python. Specifically, we're going to focus on print, input, and the int function. Variables are just a name that we give to a value. If you ever took math, we had variables. Typically, it was called X or Y. In Python, we're going to give variables a little bit better names so that we know what we're talking about, but they're still just placeholders for information. They have to start with a letter. So you see we have a lowercase a to z or a capital A to z. They can also start with an underscore. Once you put that first letter or underscore in there, you can start using numbers. So that helps whenever we start having variables, like name one and name two, so that we can keep track of different things. And we'll see that in a little bit. Python has some keywords that we can't use. So they're going to have special meanings for words like if, for, else. There's a list of them. I will show it to you, but it's just words that Python needs to reserve for their own purposes. And they're helping us out by letting us use their language. So it's just fair that we don't mess with the stuff that they need. Names are case sensitive. So you see it, the first bullet, we have a lowercase a through z and uppercase a through z. If I have name as a variable with a capital N and name with a lowercase n, that's two different variables. So we have to be real careful with that. Creating variables in Python is fairly simple. We use the equal sign to say whatever's on the right side goes into the variable that's on the left side. For example, you can see I have Bob inside single quotes, and that's going to be stored in the variable named name. Same thing underneath it, I have programmer inside a double quote, and that is going to be saved as the variable named job. You can also see we have 72, which is a number, specifically an integer, that we're going to be storing as height underscore in underscore inches. Now that we know how to store our data, we need to be able to tell what the different types of data are. So we had Bob earlier and programmer in 72, but these are different data types that we have to handle differently. So the main data types that we have are going to be integers, float, and string. There will be other data types, but these are the three main ones that we consider to be primitive data types. So the first one that we have is integer, and we also call it int. So these are just numbers that don't have a decimal. They can be positive, they can be negative, zero as well. So when you were learning to count in basic math in elementary school and middle school, these are most of the numbers that we dealt with. When we have decimals, those are called floats. These are more precise. So whenever we have, for example, negative 2.0, it's still negative 2, but we're showing that as more precise. So float data types give us that extra precision. Finally, we have strings. And strings are just collections of text, letters, digits, characters. So if I have two words and I have a space in between them, that is actually a character. And you can see I have single quotes on the numbers 1, 2, 3, 4, 5, and then I have double quotes on hello. So I can use either one. I just can't use a single quote on one side of my string and a double quote on the other side. I have to have a matching set. Now that we have data to work with, we need to start using operators to use these characters and strings and ints and floats in ways that are logical. So the operators that we have, a lot of these look very familiar from whenever we were taking math classes. We have addition and subtraction, multiplication, and division. But we also have some new things that have been added in. Exponents at the top should make sense. We still know 2 squared is 4. This means multiplying something by itself. So 2 to the third be 2 times 2 times 2, which 2 times 2 is 4, times 2 again is 8. So that's our exponent. Modular division means do the division, but when we're done, I just want to know what the remainder is. It's kind of an odd thing, but we use it a lot inside loops whenever we're trying to find a certain number of processes. So let's say I want to do every third step, then I would use modular division of 3, and every time that I had a remainder of 0, then I would do whatever activity I wanted to do. It's something you're just going to have to kind of see it in process, and it'll make sense. But until then, just remember it gives me the remainder. And then integer division, whenever I divide two numbers, typically I'm going to get something decimal wise. So integer division takes whatever I get and it just removes the decimal part. So if I have two numbers that give me, for example, let's go ahead and move to the next slide. So you can see with the integer division, I have 5, integer division 2, it gives me 2. Now, we learned in math 2.5, which you can see right below it, would round up to 3. But since we are using the double division sign, then that means it just removes that decimal. And you can see how the exponents work. 2 to the power of 3 gives me an 8. 5 divided by 2, well, that's 2.5. Well, that 0.5 is a remainder of 1. So you can see in the modular division, it threw away my 2, and it kept the remainder, which is 1. Once again, that integer division, it got rid of everything that was behind my 2, so it ignored my remainder. Regular division or float division, I take two integers, 5 and 2, and I divide them, and then I get a float. When I multiply, that standard 10 times 3 is 30, as we expect. And subtraction and addition, those both work the same way that we would expect as well. If we're working with floats, you can see a lot of this operates the same way. 2.0, it's still 2. We just showed that we have the precision of the 0.0. So 2.0 to the power of 3 is still 8, but now it's 8.0 because I get a float whenever I use a float in the mathematical operation. Same thing with modular division. 5.0 modular division 2 is going to give me a remainder of 1, and that's going to be returned as a float. Now, integer division, this one is specific. It always returns an integer, so it still rounds down to 2, and it doesn't put a point on the end of it because we threw away that precision that would have given us the 0.5. And then division and multiplication, subtraction and addition, they all work the same way. Notice I'm multiplying and dividing and subtracting and adding a integer to my float, but I still get a float. So anytime we have a float in there, unless we specify in integer division, we're going to end up with a float. And then for our last data type, we have string. Now, obviously, I can't multiply Bob times Bob times Bob. So Python's going to throw an error on me. Same thing, if I try to divide by 2, well, I can't divide Bob in half. And I don't have a logical way to do this. So I can't get a remainder either. So modular division will throw an error. integer division, regular division. Now I can multiply Bob times 3. So that would give me Bob, 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 because I have 3 of them now. Can't subtract 2, because what would I remove? It just doesn't make sense. And then the last one is kind of interesting because we have Bob plus 1. It treats that 1 like a character. So just like if I did Bob plus A, we would know that would be B-O-B-A. In the same way, I'm just adding a 1 instead. So it gets treated like another string. Now that we've talked about data types, we need to start talking about Python itself. Whenever you set up Python on your computer, asked you to run the Python command in command prompt so that we could see what version we had. And I told you at the time that you might have to type in exit with parentheses and hit enter, or just hit the X to get out of it. Because what you actually went into was an interactive Python shell. So you see the 3 arrows on the bottom left. You can actually type Python commands in there and run them and see what they will do. This is not how we're going to write our programs, but this is useful to know because sometimes you don't know exactly what something's going to do. So this is a good way to test it if you don't want to run an entire Python file or a Python program. So once again, you can get to that through the command prompt, PowerShell, terminal, bash. It all depends on what your operating system is. But for most of you, you're probably using Windows, so it would be command prompt or PowerShell. So now we're in a position that we can start writing code. And like I said, we're not going to use that interactive shell very much. It's just we use it in order to confirm that we have Python installed. Because most of what we're going to do is write our code in Visual Studio Code or another text editor that provides support for writing code. And when we start writing code, we're going to have to learn about comments. And comments, like it says here, they're non-executable lines of code that we use to explain or annotate the code. So we're writing instructions for a computer. But whenever you move into the software development world, you're not always going to write your code by yourself. So you're going to want to put comments in there to explain what you did and why you did it, because later on somebody else might have to come in and make adjustments to it. Or, and I've been in this boat several times, you have to come back many years later, sometimes a decade later, and look at that same code. And you've slipped a few times since then. So you don't remember exactly what you were doing and why you did it, but you have to figure it out again. So if you can give yourself some breadcrumbs that you can follow and figure out what the thought process was, then hopefully that will help you be able to figure out what's going on faster. So this is what comments look like. Typically in Python, we're going to use a single line. So you can see here, I have a pound sign, and it says this is a single line comment. And then underneath it, I have one that says variable x is assigned the value of 10. Now, I can look at that and see that the number 10, the integer 10, is stored in x. But this is a way for me to kind of show what comments do. Typically, as a software developer, I would not put that comment in there, but this is so that we can practice and get familiar with putting comments in whenever we're doing things that are more complicated. Sometimes I'm going to write large pieces of code, and I might want to give multiple lines to explain what that code is going to do. So I can use 3 single quotes or 3 double quotes to open up a multi-line comment, and then I close it out by giving it the max of 3 single quotes or 3 double quotes to show that I am done with my comment. And like I said earlier, they help clarify what we're doing and it makes it easier to read our code. And right now, when you're writing code for a class, it's not that big a deal. And whenever you're writing small coding projects that you're not going to have to maintain for many years, it's not a big deal. But whenever you're working on large projects in a team, or if you're working on stuff that you're going to have to maintain for several years, comments become very valuable because you don't want to have to figure out what were you thinking whenever you're trying to fix a bug at 2 in the morning and you have angry customers. Now we're ready to actually start writing code. And Python gives us the gift of built-in functions. So some of those we're going to talk about here in just a second. So built-in functions, they're predefined by Python, and they're already loaded in whenever you download Python and install it on your computer. So this keeps us from having to write some very low-level things that are actually complicated to write. So we don't want to have to reinvent this stuff. So we're going to use what they give us. And when we start working with these functions, you're going to notice that a lot of them have lowercase letters on the front. So the first one that we're going to talk about in a minute is print. And print starts with a lowercase p. And we need to make sure that we spell it that way, because the capital P print is actually a different function that doesn't exist. So if you use a capital P instead of a lowercase p, it's going to throw an error message. You'll also find that we have parentheses after these. We're not going to go into it today, but each one of these are functions, and Python always needs parentheses at the end of a function. So when we do print, we're always going to include parentheses, even if we don't put anything in those parentheses, because it is a function. So this is your typical hello world. This is the first program that everybody writes traditionally when they learn a programming language. And you can see I'm calling the function print. And inside of the parentheses, I'm passing in a string because this is a collection of characters surrounded by single quotes. And when I run that, so you see it's in a .py file, so it's a Python file, and this is in Visual Studio Code. I could run it by hitting the triangle in the top right. It looks kind of like a play button. And it uses PowerShell to run it in the bottom, and it says Python demo.py, and it says hello. So that means that I'm running my demo.py Python file that I wrote with the Python program that was installed on my personal computer. And when I run my demo.py file, it has print hello inside of it. So Python printed hello. So now I want to get a little more complicated. I also get a function from Python called input. Whenever I said print, I'm able to make statements. So, for example, I said hello a minute ago. You can see on line 5, I print, you said your name is, and then I give it a variable name. So I'm making a statement again. Input lets me ask questions. So programs that we write for this class, we're typically going to be talking back and forth with the user through command prompt. And you can see down below, I run demo.py with the Python program I installed on my computer. And it will ask the question, what is your name? Well, that's because on line 2, inside my input function, I put a string that asks, what is your name? So when I run this code, it's going to print out what is your name, and it's going to wait for an answer. So we want to write programs that are polite. So we're going to ask the question, what is your name? And then we're going to wait for an answer. And on top of that, when we get the answer, we want to remember that answer. So we're going to put that answer into our variable name. So now I've asked, what is your name? I've typed in the name Bob and hit enter, and it stored the string Bob in my variable named name. And then I go down to line 4, but line 4 is a comment. So that's important to me. But Python ignores it, and it goes on to line 5. And it has a new command. So the function print, and it sees the string that says, you said your name is, and I have a comma, and the variable name. So print, you're going to have to play with it a little bit because there's some different functions that it has, and you'll see them inside the book as well. But I can print multiple things using the print function by using a comma to separate out strings and variables that hold strings. So in this case, I'm able to print out, you said your name is Bob. So now that we have a way to make statements through print and ask questions through input, we need to start supporting numbers. So I've added in how many apples do, oh, that is an awful grammar statement. How many apples do you have? It's supposed to be at home, not a home. So how many apples do you have at home? And that's the joys of working with computers. It doesn't care that I misspelled it. It's just going to ask the question the same way. So if we look down below, it asks the same question with my typo. And then it waits for me to give it a number. Same thing with the oranges. It waits for me to give it a number. So you can see, I said I have 3 apples at home. I have 4 oranges at home. And then it says you have apples plus oranges. So you have 34 pieces of fruit at home. Well, this is a problem. And obviously, my code does not print that with that glitch in the matrix. I added that in a little differently. But we have a problem because I was wanting to add my 3 apples and my 4 oranges and say I have 7 pieces of fruit. But it didn't work that way. Instead, it took my 3 and my 4 and it put them side by side. But that's because I have them as strings. So we talked about integers or numbers that do not have a decimal, and floats are numbers that do have a decimal, and strings are just characters. So we're treating 3 and 4 like we would any letter in the alphabet, and we are not treating them like numbers. So when we add letters of the alphabet together, we just put them together into our sentence and move on. So that's what Python did because I wasn't clear when I gave it instructions. So now I've made an adjustment, and you can see I still ask the question, how many apples do you have at home? And put it into the variable apples. But now I'm taking apples and putting it into a function called int, int. And int is going to turn that string into an integer. Now, at the same time, if somebody were to put, no, I have no apples, so no, well, no can't be converted to an int. So that would throw an error message. But for our purposes, if I put 3 in for apples, then I get a string 3 and apples. I turn that string of 3 into the integer 3. Well, now I have a number. Same thing with oranges. If I put in 4 for oranges, well, I entered a string. So now I have to turn that string of 4 into a number 4. But whenever I add the numbers or the integers 3 and 4, I now get 7, is what I was looking for. In this video, we talked about variables and data types, and then how to use operators to work with those data types. And we talked about the interactive shell, that we're not really going to use the interactive shell that much, but it does exist. We discussed comments and how to add them into our programs. And then we worked a little bit with 3 built-in functions. We have print, input, and int. If you look through your textbook, you're going to find that there's more details around all this stuff. And also there are some videos there included. They're going to walk through some programs that will help you see this stuff. Learning to write programs, it's kind of like learning to ride a bike. You're going to have to just do it. And it's going to be rough at the start. You're going to get error messages. I still get error messages. It's just part of it. But the more that you write code, the easier it's going to get over time. So get in the book, get in the programming videos, and just start trying out writing some code. And as you try it out, it's going to make more sense to you.